Welcome to Data Affairs with Intro. Today we'll be dealing with a topic wherein we will be going through a pedagogy which is being followed by the Harvard University to understand deeply about the data, its inferences, and wherein we'll be seeing all the central tendency calculations like mean, mode, median, and we'll be also looking into the percentile ranges calculation, standard deviations, variances, and so on. And also the data realistically concepts like what will happen if a whole of the data set is being increased by a certain percentage, or if a whole of the data is being increased or decreased by a certain number. What are the changes which will happen in the data set, and what are the various changes which will be happening on our central tendencies inferences. So let's start with it. And we do have an as each initial data set of 5 elements, which is I is equals to 10, 20, 30, 40, 50. These are the 5 elements. So let us calculate the mean, which comes out to be basically 10 plus 20 plus 30 plus 40 plus 50 by 5, which is exactly equals to 30. So here mean comes out to be 30. Median, since I have already arranged it in an ascending order, so it could have also been arranged in a descending order, but leave it out. We have already previously arranged it in an ascending order. Therefore, since it's an odd term, elements count, therefore this middle one would be the median. So median also comes out to be 30. So here mean is also 30, median is also 30. And now we need to calculate what is deviation. So deviation is basically how each of these data sets, each of these elements within the data set is how much far away or nearer to the mean value or the median value, basically how much it is closer to the median value. So now how much is it closer to it? So we see how do we calculate it. So it would be 10 minus 30 comma 20 minus 30, likewise 30 minus 30 comma 40 minus 30 comma 50 minus 30. So this deviation would also be forming a data set, that is minus 20 minus 10 0 plus 10 plus 20. So this is the deviation data set which we have now. So how do we calculate variance? Variance is basically, how do we calculate it? Squaring out the deviances and then divide it by the number of counts of those deviances. So let's see, minus 20 square plus minus 10 square plus 0 square plus 10 square plus 20 square divided by 5. This comes out to be 1000 by 5. This is equals to 200. So variance is 200. Next up is standard deviation. Although we haven't done any formula related to this within our series, which we'll be looking at afterwards, but just look into the concepts of this. We can also we can regularly use formulas and just get the data from it, but what is actual figure, what is basically a visual imperiences between them, how do we differentiate between the data which we have, and what is the deviation, what is the variances. Visual aspect is very much essential. That's why I'm doing it in this method, that by step by step, by calculating the deviation, and then from that deviation we are coming into variance. This is basically the steps that we should follow in calculating the various identities. Now standard deviation, how do we calculate it? It is basically square of variance. So variance, what we have got, 200. Therefore square of variance is, this would come out to be 10 root 2. Just mark these inferences that we are getting, these values. Standard deviation is 10 root 2, variance is 200, and here the deviance data set was this, and mean and median both were 30, and n is equals to 5, and the data set was 10, 20, 30, 40 and 50. So I think we have it. And now let's start with this. So the next up, I am just removing this, and next up just take a screenshot. So see, let's calculate. I'm also rewriting it again, that the data set 10, 20, 30, 40, 50. So now let's calculate the 25th percentile. We had mean is equals to 30, median is equals to 30, and deviation data set was given, and I guess variance was 200, and standard deviation which we have got is 10 root 2. Think this is visible? Is 10 root 2. Yeah, so this is what I've given it over here. So now 25th percentile would be index position. Let's find out the index position of that value would be p by 100 into n plus 1. Therefore p is 25, therefore 25 by 100 into 5 plus 1 is 6, 4 is 3 by 2, which comes out to be 1.5. Therefore what's the value? 25th percentile value is somewhere here, so how much it would be? It would be 10 plus 20 by 2, that is 15. This is the 25th percentile value. And now let's calculate the 75th percentile value. How much it would be? Again 75 by 100 into 6, I am doing it directly, and the value would be 9 by 2, which is 4.5. So here it was 1.5, here it is 4.5. So where should it lie? It should lie, therefore the value would be, this is the index position, basically index position is 4.5, and the value would be for 75th percentile value is basically 4.5 is this one, 1 2 3 4, and this is 5, therefore in between. So 40 plus 50 by 2, this is 45 here. So 45 is 75th percentile value. What we have called this is the third quartile. This is the first quartile value. These things we have done it on the previous class. So this is the third quartile, and this is the third quartile, and this is the first quartile value. So let us calculate the interquartile range. Interquartile range is what? Interquartile range is the value between the third quartile value and the first quartile value. Therefore the third quartile value is 45 minus first quartile value is 15, which comes out to be 30. So see how, what a coincidence is this? We have mean to be 30, we have median to be 30, we have interquartile range to be 30 in this data set which we have taken, and the standard deviation was 10 root 2, the variance was 200. Okay, so we shall be keeping these inferences or conclusions that we have in mind, and let's take a scenario wherein we'll be seeing that what will happen if each of the elements in this data set, this is 10, 20, 30, 40 and 50, is increased by 10%. So then what is the figure? What all would be the changes we'll be having in all these data calculations points which we have done for the initial data file. Let's see. So we are increasing. This can also be done for the decreasing part. I am also only doing it for the increasing part only. The similar can be done for the decreasing part. I am doing it for the increasing, and you may also give me the results in your comments by doing it for the decreasing part. What is the results that you are getting and what are the inferences that you are getting? If we increase each elements by 10%, what will happen? So initial data set was 10, 20, 30, 40, 50. New data set, what will it become? It would be 10%. So 110 by 100 into 10. What is it coming out? Why it is 110? We are increasing the value 10 by 10%. Therefore 110% of 10, comes out to be how much? 11. So likewise this would come out, if you calculate, this would come out to be 22, this would come out to be 33, this would come out to be 44, and this would be 55. Fine. So let's calculate mean. Mean would be, again summing this up and then by 5, it would come out to be 33. Median, see the middle value is 33, therefore it would be also 33. Deviation data set. Deviation data set would be how much? 33, 11 minus 33. This would come out to be minus 22. 22 minus 33 minus 11. 33 minus 33, this would be 0, and then 44 minus 33 would be 11, and likewise this would come out to be 22. So now calculate the variance. How much it will be? So minus 22 square plus minus 11 square plus 0 square plus 11 square plus 22 square by 5. This would be how much? This would be 242. 242 is the variance. Previously what we have got? Previously we have achieved 200 as a variance in our initial data set of this one. And now standard deviation. Standard deviation would be how much? Root over of 242. This is root over of 2 into 1 to 1, which is 11 root 2. So now the standard deviation is 11 root 2, and previously we had 10 root 2, if you can remember. Now let's calculate the 25th percentile. 25th percentile value would be, again see, 25 by 100 into 6, which the index point would be remain same for each case. So 1.5 is the index point. So let's check. And for 75th percentile it would be 4.5, which we have already calculated. The index position would be 4.5. So the values would be different in this case, not the similar. Index point will be similar in each and every situation, because since the number of this count, that is n value, is same for each case, but the value for different situations will be different. So let's check wherein 1.5 is lying. 1.5 would be here. This is between 11 and 22. So we'll be again taking average value of this. So 11 plus 22 by 2, this would come out to be 16.5. So 16.5 is the 25th percentile value. That means 25% of the data within the data set is less than 16.5. Fine. And next up we have values for 75 percentile. What will be to range? It will come. It will be like, say here, that is 44 plus 55 is 99 by 2, which would come out to be 49.5. So see, we have 25th percentile value as 16.5 and 49.5 value as the 75th percentile values. So therefore the difference between these two comes out to be interquartile range, which again comes out to be 33, which is similar to the mean median. Am I right? So please take a screenshot for this. Then we'll be moving it to the another situation which we have. Now see, we had previously the initial data set was 10, 20, 30, 40 and 50. And now if we take another scenario wherein we are increasing each element by the number 10, that is we are summing increasing this 10 figure to 20, likewise 20 to 30. Okay, so plus 10 is happening. Okay, in this case, so I am doing it for the plus 10, that is for the addition by increasing it by 10. You may also do it for subtracting by subtracting in, that is by decreasing it by 10. What the values comes out to you and what are the conclusions, you may give it into, you may give it to me into the comments, and let's check what will happen. So the new data set would become like 10 would become 20, 20 would become 30, 40, 50 and 60. That is the topmost range would shift from 10 to 50, from 10 to 50 to 20 to 60. Okay, but the range remains same. In between range remains same, that is in between range is between, how do we calculate? 50 minus 10 comes out to be 40 and 60 minus 20 is also 40. Therefore the in between range remains same, but the range moves towards the higher side, in this case by how much figure, that is by 10. So now let's check what would the mean become. Mean nu would again become how much, by adding this 20. You may also know this formula, like if you use this formula that n into n plus 1 by 2, this is basically a formula wherein we take the calculations for the sum of first n natural numbers. Why I am using it sum of first n natural numbers? This formula may be used for summing up the value. If I take 10 as common, what it come out to be 20, 30, 40, 50, 60, and then again you may also subtract minus 1 to gain, since it is not starting from 10 in for previous, and if you start previous figures wherein the figures were starting from 10 only. So in that case, if 10 was there, then we could have directly used it at figure as n into n plus 1 by 2. This can be used if the data set is having enormous amounts of elements. Okay, if the number of elements are large, so for in that case we may use this formula to calculate the sum, and then by dividing it the count of the number of elements into the data set, we may get a mean value. We will directly, since the value is since the number of elements in this case is small, it's only 5, so we'll be doing it by summation only. So let's check what will it come out to be. 20 plus 30 plus 40 plus 50 plus 60 by 5, which comes out to be how much? 40. Okay, so now the new mean is 40. What would be the median? Median would be the middle element. This is also 40. Okay, now deviation. Let's check the deviation data set. What would it be? So 40. So 20 minus 40 comes out to be how much? Minus 20, minus 10, 0, plus 10, plus 20. This is the deviation data set. Which would it come out to be? And then standard deviation. Sorry, after deviation we would be going to the variance part. Variance. Okay, so the variance, how do we calculate? Variance would again minus 20 square plus minus 10 square plus 0 square plus 10 square plus 20 square divided by 5. If you check, we have done this previously for the initial value which we have calculated. So these were also the data set for the previous data figure. So this figure is common to us, is known to us basically. This would be 200 only. Standard deviation next. Standard deviation would be how much? Standard deviation would be, so the known figure 10 root 2 root over of 200. So now we have mean to be 40, median to be 40, and variance to be 200, standard deviation to be 10 root 2, and the deviation data set is similar to the previous one. So now let's calculate the 25th percentile index point. It would again remain to be 1.5 for 25th percentile, and for 75th percentile the index position would be 4.5 since n value is same. So value for 25th percentile would be what? Between this, and value for 75th percentile would be in between this. So value would be 20 plus 30 by 2, which comes out to be 50 by 2, that is 25. And here the value would be 50 plus 60 by 2, which comes out to be 110 by 2, that is 55. So see, the 25th percentile value is 25th, which is in between 20 and 30, that is 25, which is true, and between 50 and 60 it comes out to be 55. So in between this range is called as to be the interquartile range. Interquartile range comes out to be 55 minus 25, which is again 30. So check here, in this case interquartile range is 30, mean is 40, median is 40, deviation data set is similar to the initial data set, variance is 200, and standard deviation is 10 root 2. So now my job would be to summarize all these inferences that we have got. Let's check. See, initial data set. Initially, if I write it down as initial data sets figure 2, while my elements is increased by 10%, each each element is increased by 10%. What's my inferences are? Now check. Mean was 30. Here also mean was 33. Here the mean is 33. So if you check change in mean, if you calculate change in mean, it would come out to be how much? 33 minus 30 by 30 into 100, which is equals to 10% increase, which is equivalent to the percentage increase of each element. Fine. So next up, let's check for median. Median was 30. Here median is how much? Median is 33. So again, change in median value would be, it would again come out to the same values, therefore it would again come out to be 10% increase. Okay, so here also median is increasing by the same percent to which each element was increased to. Next, we had standard deviation. So standard deviation standard deviation is 10 root 2, and here standard deviation comes out to be how much? 11 root 2. So if we check out for the range, that is change in standard deviation, it again comes out to be 11 root 2 minus 10 root 2 by 10 root 2 into 100. This is actually coming out to be 10% again increase. Okay, so there is again an increase of 10% in the standard deviation, which is equivalent to the percentage change in each of the element which we had previously. So let's check for interquartile range change. Interquartile range value was 30 in this case, and in this case interquartile range value was how much? Interquartile range value was 33. Am I right? It was 33. So again change in interquartile range value would again sum up to 10%, which is the calculation is similar to the mean and median which we have did earlier. Therefore we may conclude here that, and one thing more which we shall concentrate upon is here, see, mean is equals to median is equals to IQR, this is equals to 30, and here also mean is equals to median is equals to IQR, that is interquartile range, which is equals to 33. Okay, so in all these three identities we had an increase of the percentage, that is 10%, which is equivalent to the percentage increase in each of the elements which we had. This is the particular inference which I was trying to get a concept of what will happen if there is an increase in certain percentage or a decrease in certain percentage within the data set. Okay, I guess this is fine, and the difference is quite clear. One may take a screenshot if necessary. I am moving on to the difference that I will be having when there is an increase in each of the numbers by 10, as in values. And this one may keep in their mind that this is not basically because of the figures which we have taken, that is the elements which we have taken in our data set. This is valid for any of the elements which we will take in as our sample data set. Okay, so let's move for the next difference. So again I'm comparing initial and final is basically when we are increasing each element within the data set by 10. Okay, that is plus 10 is happening in each of the data set. Okay, an initial data set was basically 10, 20, 30, 40 and 50, and here it was 11, 22, 33, 44 and 55. So now what we had, mean was how much? Mean was 30. Here mean came out to be 40. So change in mean is equals to 40 minus 30 by 30 into 100, which comes out to be how much? 33.33% increase. Okay, so there is an increase in mean of 33.33% when we are increasing each of the element by a value which is equivalent to 10. That means 10 value in the initial data set becomes 11 in this case. So now check it for median. Median previously was 30 and here median was how much? 40 again. So you would again see change in median would be how much? It would again come out to be 33.33% increase in the value. Okay. Next up is this thing. I'm writing it down, but there is no such difference into it. The deviation data set would remain the same basically. Here also minus 10, 20, minus 10, 0 and 10 and 20, and here also deviation data set would be minus 20, minus 10, 0, 10 and 20. Next up we have what? Standard deviation. So standard deviation, so STD, standard deviation would be how much? Difference. Standard deviation is basically, here it was how much? In this case it was 10 root 2 and in this case also it comes out to be 10 root 2. So are you getting why I am writing? I had written the deviation point here and not previously, because we completely had a difference in the deviation data set previous hand, which was evident that minus 10 figure, minus 20 figure came out to be minus 22 when there was a percentage increase of 10% in each of the elements. And here if you look at see minus 20, minus 10, 0, 10 and 20, and likewise it is similar in this case. Therefore, since there is no deviation change in deviation data set, or there is no difference between the deviation data sets in both the cases, therefore we don't have any difference in the standard deviation point of view. So there would be no change in standard deviation point of view. Okay, so the change would be nil. I would writing it down, change is equals to nil. There is no change basically. Next is IQR. For IQR, if you see, we had IQR to be 30 and here IQR is 30. So since there is no change in the deviation data set, there is no change in the standard deviation, and thereby we also conclude that on increasing the figure, that increasing each of the elements of a data set by a certain figure, which in this case is 10, there would be no change in the IQR values. So IQR remains same. Fine. So the difference is completely evident in this case. So here if we see, the IQR value is again here also let's write it down, that mean is equals to median is equals to 30 and IQR is also 30. But here if you see that mean is equals to median is equals to 40 and IQR is equals to 30 in this case. Okay, so IQR value is equals to 30. So these are certain differences which one must keep in mind while if you are given certain data set and if you are asked to analyze certain data set basically, then one must keep in mind that what are the factors which are affecting my data elements of the data set basically. If a certain number in certain case is decreased by 10%, what will happen? All the differences which we have catered on the previous part, that is while we were catering the percentage increase, similar percentage would be in the decrease side. So if the mean has increased by 10% previously when we were increasing each of the elements of the data set by 10%, if we decrease that value, that if we decrease it suppose by 10%, then the value would again the mean the change in the mean would come out to be a decrease of 10%. This is basically the conclusion which one must keep in mind while analyzing data. And the next up calculation for the decrease part one may do, and may say me up that what is the figures that they are getting, or the factors which are affecting over there, and what are the results that they are getting in the comment section. I think if you have liked the video, please press the bell button for the next videos to follow, and make a like, share and subscribe to the channel. And that's all. Wait for the next video until we have our next meeting. Thanks up.